Imagine the tire as a collection of springs around the wheel. If all of the springs are identical, the assembly will roll nice and smooth as it is loaded and rolling down the road. But if one of the springs is stiffer, every time it contacts the road, it will push the spindle or axle up. At road speeds, this condition will cause vibration. A vibration is unrelated to balance. Hunter's road force balancing system measures force variation using a load roller against the tire that simulates a test drive. During the measurement cycle, readings are taken around the circumference of the assembly and then displayed as pounds force on the screen. Force matching is a procedure that allows you to match the stiffest spot of the tire with the lowest spot on the rim and optimize the assembly. Here's a basic overview. Once the tire is measured by the load roller, the rim run-out measurements can be taken. When this is complete, the computer displays the low spot on the rim and the stiff spot on the tire. Index marks are placed on the tire and on the rim in their respective locations. Using a tire changer, the tire is loosened from the rim, and the index marks are matched. After setting air pressure to specs, the assembly is mounted on the balancer to check the results. Before measuring road force, it is important to implement the following initial steps. 1. When mounting the tire to the rim, be sure to use proper mounting lube to achieve accurate seating between the tire's beads and seats on the rim. 2. Measure and adjust air pressure to the specified limit. And 3. Don't measure tires that have temporary flat spots. This can happen when the vehicle is parked or stored in one position for an extended period of time. If required, drive the car to warm up the tires and relieve the flat spots. Begin the measurement sequence by selecting the collet that best fits the center hole of the wheel. Using a collet is recommended to achieve the best centering. Refer to the basic balancing video for proper mounting techniques. Accurate mounting is critical for achieving accurate road force measurements. For vibration diagnostics, always select road force instead of quick match. Quick match should only be used for an assembly audit. To turn off quick match, press the Shift key once and then select Disable Quick Match. Now, close the hood and measure the assembly. Road force measurements are taken first. Next, imbalance is measured. When complete, the road force results are displayed here in pounds. If the measurement is flagged red, it has exceeded the limits, and this display will pop up automatically. Default limits for road force are preset at the factory and vary according to vehicle category. For example, limits for passenger car and SUV assemblies are set at 26 pounds. For light truck, the limit is set at 39 pounds. It's important to understand these limits are good starting points, but will not apply to every vehicle. Some vehicles are much more sensitive than others. To begin the force match procedure, check to be sure all wheel weights that may interfere with run-out measurements are removed. Then, press the Shift key once and select Show Runout and Force Matching. Or, from the Road Force pop-up display, select run out, and force matching. Next, measure rim runout. On this wheel, place the inner dataset arm here, the outer arm here, and press the outer arm button to initiate the procedure. For the best measurements, hold the arms in place with your fingertips. When the wheel stops, the display will update and show the measurements and the index mark locations. Press the Start button to servo the tire index location to top dead center. Mark the tire. Press the Start button again to servo the wheel index location to top dead center and mark the wheel. On the tire changer, loosen and lube the beads to match the index marks. Inflate to specifications and recheck the assembly on the balancer. To measure runout with a bare rim, mount the wheel as previously described. Select Runout Matching and then press Measure Bare Rim. Using the outer arm, switch from the roller to the ball tip and place the ball here at the inner bead seat area. Press the button on the arm to rotate the wheel. When the display prompts, move the outer arm to the outer bead seat area and press the button again. When the measurements are complete, place a reference mark on the hub of the balancer and then on the rim. So, after the tire is installed, the assembly can be realigned with the hub and shaft. This runout data can be recalled and used from the force matching display by selecting Apply Last Rim Data. To avoid having to use the dataset arms for force matching, use the 180 method. To do this, select Runout Matching from the Force Match screen and then select Match Without Rim Runout. Lower the hood to measure the assembly. Now, position the valve stem at 12 o'clock and press Enter Valve Stem. Mark the tire with a V opposite the valve stem. And press OK or depress the foot pedal. Remove the assembly from the balancer and on a tire changer. Loosen the beads and rotate the rim 180 degrees relative to the tire. Inflate the tire to specifications. With the assembly mounted on the balancer, position the valve stem to 12 o'clock and press Enter Valve Stem. Close the hood and measure the assembly. When finished, the measurements will be displayed. Note that rim runout measurements are not displayed because they are not measured during this procedure. To measure runout using only the inner arm, you simply start with both. But then, store the outer arm once the assemblies begin rotation. Although this method can be used when the outer bead seat is not accessible, it is not preferred because the results are normally less accurate. For additional road force training, or training on other features of Hunter's road force balancing system, contact your Hunter representative. To find your local rep, go to our website at www.hunter.com. Thank you.